The present status and features of OTEC. Myself Binoy Poyili, Assistant Professor, Department of Mechanical Engineering, Vedavyasa Institute of Technology. The OTEC, Ocean Thermal Energy Conversion, is an energy technology that converts solar radiation to electric power. The OTEC system uses the ocean's natural thermal gradient, consequently the temperature difference between the warm surface water and the cold deep water. OTEC utilizes the ocean's 20 degrees centigrade natural thermal gradient. The oceans are thus a vast renewable resource with the potential to help us produce billions of watts of electric power. The OTEC uses water from the bottom of the sea, which is nutritious. One result of this is that a lot of fish and other seafood will be collected in the outlet flow. This means that OTEC not only produces electricity, it produces water and food too. The background information. The oceans cover a little more than 70% of the Earth's surface. This makes it the world's largest solar energy collector and energy storage system. On an average day, 60 million square kilometers of tropical seas absorbs an amount of solar radiation equal in heat content to about 250 billion barrels of oil. If less than 1/10 of 1% of this stored solar energy could be converted into electric power. This is the closed cycle OTEC system. In closed cycle OTEC system, warm seawater heats a working fluid such as ammonia with a low boiling point, which flows through a heat exchanger called evaporator. The ammonia vapor expands at moderate pressures, turning a turbine which drives a generator which produces energy. The vapor is then condensed in another heat exchanger called condenser by the cold, deep ocean water running through a cold water pipe. The ocean thermal energy conversion open cycle system. The warm seawater is the working fluid that is pumped into vacuum chamber where it is flash evaporated to produce steam at an absolute pressure of about 2.4 kilopascals. The resulting steam expands through a low pressure turbine that is hooked up to a generator to produce electricity. The steam that exits the turbine is condensed by cold, deep ocean water, which is returned to the environment. If a surface condenser is used, the condensed steam remains separated from the cold ocean water and can be collected as a ready source of desalinated water for commercial, domestic, or agricultural use. This is the OTEC hybrid cycle system. The hybrid plants combining benefits of the two systems would use closed cycle generation combined with the second stage flash evaporator to desalinate water. The plant design and location. Land-based power plant. The land-based pilot plant will consist of a building. This building will contain the heat exchangers, turbines, generators, and controls. Warm water is collected through a screened enclosure close to the shore. A long pipe laid on the slope collects the cold water. The floating plants. Instead of using the warm water pipe, the floating OTEC plant could simply draw in the warm water from the surface. But storms and high seas can interrupt the water flow and cause major damage to the plant. This problem could be solved by using flexible polyethylene to attach the pipe to the bottom of the plant. This is a representation. The advantages and the disadvantages. The main advantages are OTEC uses clean, renewable, natural resources. Suitably designed OTEC plants will produce little or no CO2 or other polluting chemicals. OTEC systems can produce fresh water. There is enough solar energy received and stored in the warm tropical ocean surface layer to provide most, if not all, of present human energy needs. Disadvantages. The OTC produced electricity at present would cost more than electricity generated from fossil fuels. The OTC plant must be located where a difference of about 20 degrees centigrade occurs year round. Ocean depths must be available fairly close to shore-based facilities for economic operation. The construction of OTC plants and laying of pipes is coastal. Waters may cause localized damage to reef and near-shore marine ecosystems. The benefits of OTC: dependable constant energy source, fresh drinking water, air conditioning, refrigeration, sea salt and minerals. Desalinated water. The desalinated water can be produced from either open cycle or hybrid OTC plants. In an open cycle plant, the warm water, after being vaporized, can be recondensed while being kept separate from the cold seawater, leaving behind the salt and providing a source of desalinated water fresh enough for municipal or agricultural use. The condensate is relatively free of impurities and can be collected and sold to local communities where freshwater supplies are limited. The seawater air conditioning. The seawater air conditioning, simply called SWAC, pumps cold seawater is about 5 degrees centigrade to a station via deep sea pipeline to a cooling station on shore, where it is used to cool fresh water, which is then piped to a building's air conditioning system via chilled water coils. Mariculture. Cold, deep seawater brought up by OTC pipes is nutrient-rich and parasite and free and can be pumped into onshore ponds producing algae or other products in the controlled system. This cold water has also been used to grow temperature crops such as strawberries in tropical climate. The OTC research and development history in India. The Indian OTC program started in 1980. In 1984, preliminary design for a 1 megawatt closed Rankine cycle floating plant with ammonia as working fluid. In 1993, National Institute of Ocean Technology (NIOT) was formed by the Department of Ocean Development. NIOT aims to build a 1 megawatt floating OTC plant off the coast of Tamil Nadu near Tuticorin port on the southeast coast of India. The following are the baseline design conditions. The gross power output is about 1 megawatt. Warm water temperature is about 29 degrees centigrade. The cold water temperature is about 7 degrees centigrade. The cold water intake is 1000 meter and cold water pipe 0.90 meter. This is the OTC demonstration plants in the world. The future plants. It is postulated that the most of the future commercial OTC plants are closed cycle floating plants of 10 to 50 megawatt range. The capital cost of the plant is depending much on the heat exchanger cost, and hence any improvement in the performance in this single component is an added advantage. New materials for the cold water pipe is to be developed to withstand the marine conditions and also for easy fabrication and deployment. As the floating plants are away from the seashore, underwater power transmission to the land is an area needed further study. The design of the barge also requires care so as to position the seawater pumps. The demonstration of 1 megawatt Indian OTEC program is expected to contribute in a large way to provide this confidence to the future. OTEC, which has a potential to become powerful solution to the three greatest global issues of energy, water and food. In conclusion, OTEC and the derivative technologies would offer the best promise to bring humankind prosperity beyond measure in the 21st century. Thank you.